This is Tyson, Missouri. He's CEO at Scanse. And Scanse, and they've just produced their sweep Lidar, and he's got some other things here to talk about. Go ahead, Tyson.
Yeah, so I'm a CTO, and so we've got a small company that's been developing Lidar, trying to help out people trying to develop mobile robots in a lot of different fields, also not just ground robots, but drones and other things. And just recently, in the last month and a half, we decided to make a 3D scanner, or a spherical scanner out of our 2D Lidar. You've probably been seeing a lot of Lidar around here, but we've got a new one that looks very similar, but has some different features. So this guy, I just did a little Servo magazine article about it. Thought I'd kind of give a quick demo of what it can do. Do we have
get that video?
Yeah.
Walking up here like a little blue. Is that you?
Yeah. So it's a bunch of components you're probably familiar with. A little Raspberry Pi in the middle here with a USB battery, pretty standard fare. It's running a little web server that allows us to log in and run some scans remotely. So I thought I'd go ahead and do a quick scan of this environment. One of the big things that's neat about this little guy is it's, of course, high safe. You wouldn't want to do it here otherwise. Let's just call it a test. Oops. Do a nice quick one. So, is everyone here familiar with what Lidar can do? It seems like.
He's got a question.
Yeah.
No,
oh, are you familiar with what Lidar can do?
I work for a company called Lidar, so we're doing it for all of
Yeah. Okay. Yeah. So there's a lot of work being put into this field right now, mostly for autonomous vehicles. This guy's more oriented towards survey type applications, or well, survey applications in consumer spaces. So for like trying to estimate how much property you need for a job, or how big a tree is that you're about to cut down. So we just released this about 2 months ago, and we're just starting to get feedback from the first beta testers. This guy's
so it's a 2D LiDAR, and you're spinning 360 degrees.
Right, exactly. So it's taking slices. This will take about a minute or so. 2 minutes.
How far? What's the distance on your LiDAR?
Yeah, max range is about 40 meters.
Wow.
Yeah, which is great for rooms this size, as long as you position the thing somewhat in the middle. Accuracy at very close ranges, so less than about a meter, is pretty poor, so you want to kind of keep it up on a tripod away from things.
So in this scan, you're going to be kind of fuzzy.
A little fuzzy, yeah.
Did you say it's planar, or is it doing?
So you see spinning on the top there, it's planar, and it's.
And then you're rotating the whole thing.
Yeah. Yeah.
It needs one of those Devo cones.
Yeah.
Right. All right. So that scan was completed. Let's take a quick look. It's saved. This is an earlier scan I took this afternoon. A little.
That's not
space. Here. Yeah. It's
sharp.
It's a couch.
yeah. So let's go ahead and add the one we just took here. This is a very low resolution one.
Is this using time of flight or just angle or?
Time of flight, yeah, so much better as far as there's the space.
So did you? This is raw. Is this an RViz? That's not RViz.
No, this is our own WebGL application. We do use RViz from time to time, it's just for visualizing. It's kind of the first visualizer we use actually, but we ended up making it.
So is that you on the back of it there?
Yeah, so it's seeing all the way to the back of the ring there, so it's a little bit hard to see because of the low resolution exactly the detail. But yeah, there's me.
still having trouble visualizing.
Yeah, it's hard to see on the projector screens, but that's me there.
Oh, I see you. I
Yeah.
see you.
Yeah,
Okay.
that's
Oh, and that's the ceiling.
That's the
That's
crowd.
the ceiling up there.
Yeah.
You can see him real good. You can actually see your outline really, really
Yeah. So this is the lowest possible resolution this thing could take. Highest resolution is about 10 times this amount of point data. Show you real quick.
What is the rotation rate, not for the LiDAR, but for the, to get the, all around the Z-axis?
So it's based on the resolution you choose. So if you're doing a high resolution scan, it's going to automatically take smaller steps in order to get an even amount of data.
So I guess the question would be, how long would it take to do one of the rotational LiDARs and then step to the next place, and rinse and repeat is just multiplying after that, I think.
You say how long? What was the question? Just how long would it take?
How long between jumps in the Z-axis rotation?
We can do that in random access.
Okay.
What are you currently selling? What does the suite currently go for?
Yeah, Super Sense itself is $350, and then the rest of the kit, if you want to buy it from us, is another $400.
Okay, and these are available now.
Yep.
Okay.
But you can also make the whole thing yourself if you have a 3D printer and feel like buying a bunch of little components.
Okay. Tyson Mazzari with Scanse showing the suite. Thank you very much. Shiloh, you want to come on down? Shiloh Curtis with her Run What You Brung robot.
I've got another one. I'm back for more. So this is Mango. When I showed up for my internship here at Google, they were like, "Hey, we're assigning you a mentor outside of your team, who you're supposed to just hang out with once a week and talk about your project and get to know each other." And they had this whole long list of things you could do to get to know each other, and one of them was build something together. So I was like, "Why don't we build a robot? Robots are great." And she was like, "I've never built a robot before, but it sounds fun." So this is what we made. It's an iPhone box without an iPhone in it. It has a couple of servos for these bump switches, and inside there is a Pi board.
What's it run, Shiloh?
It's running MicroPython, okay? I'm not too proud to admit it. And currently it doesn't really move around, but if I turn it on, the LEDs will light up corresponding to these bump switches in a cute way.
Hang on, let me see the LEDs light up. Thank you.
So yeah, and if I open this box up, it's just an unholy tangle of wires, but you can tell
great.
that there is a Pi board inside it.
There's an inside joke about MicroPython.
It's an inside joke.
That's it.
Very nice. All right, Run What You Brung. What else we got? Come on. Gotta keep this thing going. Rouse off, ladies and
Is there
gentlemen.
someone that could fix the camera, please?
It's just another.
No.
It's just a joke. Nothing wrong with MicroPython. It's just that it's a little bit off the
No?
path.
That's not the right one. Arthur?
I see. To encourage you.
Oh. Indecker's back.
And that's
Indecker out? No, that's Indecker. Right?
Oh.
That's the base of the original Endeavor.
straight man.
Now trying to do machine learning on
I
it.
need to talk to Dave, one of my friends is a scientist.
Normally today, but yeah, that's the idea. That is running a TK1
Thank you very much.
NVIDIA TK1.
You're doing that in the DIY car?
Yeah.
So what's going on here, Marco?
So that's actually supposed to be an autonomous car.
Oh, this is the DIY Carbot.
Yes.
Okay. DIY Car Bot Challenge happening in Oakland.
In Oakland, yeah.
Okay.
The next one is on the 16th, Saturday.
Very nice.
Usually, I think the third Saturday every month. Yeah.
Marco Walther and a DIY Robocar. Hey.